In this example, we're given a function in formula form. So the function is g of t, which is t squared plus 3t plus 1. And we want to find the average rate of change of that function on some arbitrary interval. So some numbers in that interval are unspecified. Okay, so in part A, we're going to want to find the interval on the average rate of change on the interval 0a. So a is some number. Typically above 0, and on the interval a plus h. So I'm going to show you what this all means graphically. So we'll start with a. So a, graphically, what are we trying to find? So g of t, its graph is that of a parabola because it's a quadratic. You see that one's the y-intercept. And we could find like where it crosses the t-axis or the x-axis when by making g of t equals to 0. So we'd get something that roughly looks like this. Okay, and what we're trying to do here is find the average rate of change over an interval 0a. Okay. So what does that mean again? We're trying to find, okay, geometrically the slope of the secant line going from, this is going to be a, g of a, and this point here is 0, g of 0. All right, g of 0, but it's actually 0, 1 because g of 0 is going to be 1. Okay, so we're going to do this. So I will use ARC, average rate of change, and put the interval because that's what it depends on. Well, it depends on the interval in the function, but we typically just write the interval. So this is variation of, just by, from memory, it's delta y over delta x, but you usually try to use the right letters here. So y is well, we don't have a name for the y-axis. So it's the y-axis. I'll just call it y. I won't change the name. But this is the t-axis here. So delta y over delta t. So what is this? This is going to be the y-coordinate at the end point of the interval. So g of a minus g of 0, the initial point of the interval, over a minus 0, which are the two t values or the bounds of my interval. Now g of a is what? Well, I'm just going to replace, right, a into t by a, and that's going to give me a squared plus 3a plus 1. So this is what I need here, a squared plus 3a plus 1. G of 0, you just replace t by 0, so this is why I told you before it's going to be 1, because it's a constant term of this this function, so minus 1 over a minus 0 is just a. So that's it. That's our average rate of change, but usually we try to write it down in simplified form. So you see 1 minus 1 cancels out. Well, so we're just left with a squared plus 3a over a. And then we try to factor if possible. So at the top we see we can factor a plus 3, and when we divide by a, we see we've got common factors at the top and at the bottom, so I'm allowed to simplify those. So this is a plus 3. Of course, there's a restriction. We couldn't divide by, a couldn't be 0 before, so we should maybe write this, a different than 0, otherwise it wouldn't be equal. If you do not write this down, I'm not too strict, but this is something to keep in mind. So for part B, it's almost the same thing, except that the two endpoints are kind of arbitrary. So there we've got one, let's say, which is a here, and another one, a. It's easier maybe here to think of h as a positive quantity, a plus h. Doesn't have to be though; it could be negative. And then we still have our parabola. So the idea is the same. We're going to find the slope of the secant going from between the 2 points. So this is going to be a g of a, and this point here is just a plus h, g of a plus h. And the way it's going to be calculated is pretty much the same. So a plus h. So it's going to be g of the endpoint minus g of the initial point over a plus h, right, which is my x2, right, minus x1, like that. So g of a plus h, this is something that I need. I need g of a, maybe I want to erase g of a here. G of a plus h, well, what is that? So remember, like, you can replace t by whatever you like, okay? So I'm going to replace my t by a plus h squared plus 3a plus h plus 1. Like that. So this is, by the way, how Calculus 1 starts. Okay, so you'll have seen this. You'll be better prepared than most students I've seen coming out of high school. They don't seem to focus a lot on that, but that's actually super important. Now, careful, g of a, every term in g of a gets subtracted, right? So I'm going to put a bracket because the minus is going to distribute. Okay, like that. And I'm going to do some simplification if possible. So what I'm going to do is, see at the top I've got this polynomial in a and h. I'm going to expand, simplify, group like terms, and possibly factor. So let's start by expanding. I've got a plus h squared. So this is the square of a binomial. So I know my formula by heart. A squared plus 2aah plus h squared, right? So this is like expanding x plus y squared. So x squared plus 2xy plus y squared. Well, replace a and x and y by a and h, and here you go. You've got the exact same thing. I'm going to distribute the 3 plus 1, and then the minus hits every term here. Careful, if there's one that's negative, it's going to become positive. A minus a cancels out, so I'm just dividing by h here. And finally, I'm going to group like terms. So you see, well, actually, a lot of terms actually cancel out. See, there's 1 and 1. A squared, 3a, all those are gone. So I'm just left with 2ah plus h squared plus 3h over h. And I'm going to try to factor the numerator. Now I see that every term has a common factor of h, so I'm going to take that out. That also makes me happy because I can simplify that factor of h with the one that appears below. And I'm just left in the end with 2a plus h plus 3. And at the back of my mind, I remember that this is true if h is not 0. Because there's a restriction here just before I simplify. So that's it. That's our average rate of change on this interval for that function.